containers or a... What was that? Somebody had a question?
The FBI, Sarkar, they are recording your meeting.
Oh, FBI. Oh. Okay. So, where was I? Where were I? Sorry, I lost the link.
Security?
Yeah. So basically,
you have to do some assessment about what is...
Correct. So when I say that you have to basically do assessment, that is because, for example, when you come to Linux containers, there are different kind of namespaces and there are different kind of C groups which you can choose for containers. I can show that to you if you are interested. Basically, that comes down to a choice of 12 different choices which you can make while actually choosing the right type of container. You might have to choose between different C groups and namespaces to adequately fit your application. That's where Docker comes in. Docker basically does this choice for you. But again, unlike the virtual machines, this may not be a lift and shift technology because you might have to choose wisely. That's why lot of people are actually assessing this technology, though they completely recognize the usefulness of this. For example, if you have distributed applications where you have to extract every ounce from your underlying hardware, this is the technology, because this has least amount of overhead and this is very, very application centric. So the benefits are very, very visible. Just that people are sometimes scared about the security part a bit. And networking is also something which is still a pain point, but I think we are making good progress on this.
So you mentioned earlier that the containers are sharing the kernel,
yes,
but there's also the possibility of the containers having their own kernel running within the container, right?
No, container by default, I do not know of a container which has its own kernel. See, whenever you have a kernel inside, that becomes a virtual machine. I do not know of a container which has its own kernel, no.
That is correct. So, Sajid, all the containers effectively use the kernel of the host OS itself. One of the reasons for them being so lightweight is that they don't need their own exclusive, memory manager, disk manager, etc. They leverage all those functionalities from the underlying operating system kernel itself.
Right. Yeah. So the question basically was: is that a necessary condition, or is that basically a limiting condition, or is there a possibility for it to have its kernel? But I guess
a container cannot have a kernel of its own because of the way it's being built out. If you look at the diagram that Subhranshu is sharing, that hopefully gives some idea of how this whole architecture will be built up. If you would like the option to have a kernel of your own, which gives you some other privileges, but takes away something else, then you would ideally run it on a hypervisor, because the hypervisor is the one that can actually host a complete kernel of its own.
Thanks.
No problem.
Hey, in the container model, how do you deal with, resource scheduling? Assuming you want to provide X level of service level or performance level, how do you schedule that?
Yeah, so the resource, you're talking about the resource allocation of, for example, you need this much of CPU, this much of memory.
Correct.
Yeah, it is done through C groups. I will come to that. I will actually show you a monitoring mechanism which I have been discussing. So it is done through C groups. So basically C groups is a mechanism to allocate or restrict a container from using more than a threshold. So C groups is a already existing features in most kernels of Linux, and you can just use it. And C groups also give you a facility to extract statistics of the usage of every container. I can actually show you a small demo of that. I'll get to it. Okay. So
thanks.
So this is the, just before that. So there is a very valid question, and in the minds of everybody who attends a Docker demo or is that, is Docker a replacement for LXC? Are they very different? But it is not. LXC is the base for every container technology. In fact, you will be surprised to know that one of the very major companies in the OpenStack world, or Rackspace, has gone ahead with their private cloud, the infrastructure as a service private cloud, which is based on LXC. I haven't played with it, but it was very nice to see that their recent offering actually lets you spawn LXC containers on your compute host rather than having VMs. So they are using something called Ansible and LXC in combination. We'll talk about the OpenStack and Docker integration in a bit. So the single line answer to this question, that are they replacement? No. Docker lets you do certain things on LXC in a better way. One of them is definitely the sharing part. When you basically build a container and you would like to share it, for example, that a development organization wants to share it with production, it can be very well done with Docker. We'll give you, Godwin's demo actually covers it. And this is the Docker architecture in a brief. Basically, you will have Docker clients. The main Docker component is called the Docker demo, which is running inside the host. And Docker containers are basically maintained by Docker Docker daemon, and the daemon name is actually Docker, and the clients are all connected to the Docker daemon. Docker has recently bought one company called Orchard, which has an offering called Fig. I won't be showing any Fig demo today, but I can show it in the future. Fig is basically a orchestration tool which they have, which is again one of the many orchestration tools which are being written right now. But Fig is Docker's own, so we have to keep an eye on Fig. So this is something which Docker themselves are developing. This is the basic, very basic Docker system, how it works. So basically, this is what actually Godwin will show. There, you can actually build a Docker container using an image. The image can be downloaded on the fly from something called the Docker registry. The registry has basically two kinds of Docker images. One are public images, one is private. So there are images which are maintained by the Docker people themselves, and you could actually build your own image and just push it to the Docker repository. It works very much like GitHub. So basically, if you download an image and then maybe add your name to a file and then push it back, the whole thing doesn't go back to the repository, just the diff goes, and that's why it is so fast. So when somebody actually again downloads the updated version of your image, it doesn't get the full image, just the diff comes down. That's why it is very fast. So once you have the image, you can actually build it, or you could use something called a Docker file to build a Docker container. Docker file would have instructions, and again, Godwin's demo will cover it, exactly how a Docker file looks. Docker file will have instructions. If you want your container to have certain software installed, it will actually tell the Docker engine to basically go ahead and install those software inside the image. Once you have your container ready, and once you are done with your work, you could actually save the container, commit it. It's called commitment of the container, and then you can push it back, as I said, to the repository. And the repository, if you make it public, then that container will be visible to everybody. And anybody can pull back that container to any system which has Docker and run it in a minute. That's what Godwin is going to demonstrate.
So, Subbu, one question on the previous one. What is that Docker in the green running? You have three containers, A, B, C, and then a Docker itself. Yeah.
That is the Docker daemon.
Okay, so there is Docker daemon on the right side and there's Docker engine on the left side, right? Docker engine is for development and then Docker daemon on the right side.
Basically it's the same thing. Basically the same thing. Docker daemon is basically running the container. That's what it meant.
Okay, you're showing that the Docker engine itself is running on host 2, OS2 Linux as a container.
Correct. Both are same. Docker engine and Docker are same.
Okay.
So I just wanted to show the shareability of this thing. This is actually the value add. This is actually one of the very prominent value adds which is visible right away. So whenever you are dealing with Docker and LXC, this is something which is right away very much visible. There are other value adds like the orchestration engine and everything, the better integration of Docker with many other tools, but this is something which is very prominent and loud.
So do you have to run this on each host, like host 2, OS2, or it could be one for multiple hosts?
Run what?
The Docker engine that you were showing earlier that runs as a container itself.
Correct. You have to run. So the host, for example, if you have a compute host, every compute host needs to have Docker installed. And it's a very, very small installation. It takes hardly a minute to install. It's a very, very small installation. Basically, it's a container manager which you are running. A manager which will keep track of all the containers which are being spawned under its jurisdiction. That's what it is.
Okay.
If you draw a parallel to the KVM world, for example, you have...
Arun, you are not audible. Can you be a little...
folks, can you hear me okay?
Yes.
Okay. So if you draw a parallel to the KVM world, every host needs a kernel. The kernel has KVM in it already, and you need a set of libraries to talk to your hypervisor, which is KVM, to host these instances. And that job traditionally is done by libvirt. So in every node, you will have the libvirt service running, which will translate your request to KVM to manage the various different VMs that are running on the host. So if you draw a parallel, or if you even take OpenStack, you have services running on every node that takes care of, Nova, Neutron, etc. So that's exactly what Docker is trying to do. So the Docker engine, think of it as the quote-unquote service or the library that you need that will translate your request back and forth into the kernel using the Linux containers.
Okay, thanks, Arun. So this is the thing which I was actually explaining about the diff. So we can actually show a demo of this also if needed. That basically when you have an image, you build a container, you go inside the container, and you actually do something. When you push it back, the diff only goes. So that's why it is so fast. The sharing part is that's why it's so fast. And they actually the whole crux of this is the file system they use. I think it's called the AUFS file system, which is a layering-based concept. It's an old concept, but brought again. It's I think copy on write kind of a concept. But again, this layering concept has been existing for a while. Again, Solaris is the one who I think worked on it first time, but Docker is the one who really used it well, and it is based on this layering file system concept that they are actually doing this. And why Docker? First of all, because it has really caught the imagination of a large-scale application deployment. Whenever you have a distributed kind of application the deployment, and especially in the cloud, when you have a huge amount of application being deployed and you basically do not care about the containers much. See, cloud anyway talks about this cattle versus pet thing. Here we are making them not only cattle, this is like almost robo-cattle, so you don't care about them at all. This is one level beyond the cattle analogy. This is like completely lightweight containers for your application. And basically what I have seen is if you call Dockers as your application containers, the meaning is conveyed a little bit more better. So I have started calling it application containers than just Linux containers. So having said that, I think it's the time for the demo. So Godwin, are you ready?
Yes, Subbu, I am ready.
Yes, I am actually giving you control, Godwin. Here you go.
All right. Can everybody see my screen? I hope. Can you see my screen?
Not yet.
Okay, let me do this.
Escape and go and turn.
It's coming up just slow. All right. Can you see the black screen now?
Yes.
Okay, good. So Subbu has talked about Subbu and Arun have basically highlighted key points of Docker, and I'm just going to go ahead and kind of walk through from a technical standpoint on how we can download images from the Docker repository, build containers based on those images, push those images back to the repository, and if necessary, pull those images down. So the first thing I want to talk about is, just very briefly, is the Docker Hub, Docker repository. Subbu mentioned that a lot, and so I'm just going to show you what that is. So if we go to registry.hub.docker.com, there is you would see things like official repositories here. So these are basically images that the company has created. What this means that they've basically stripped out the non-core utilities from the images. For example, the Ubuntu. A typical Ubuntu ISO file is about 1.5 gigabytes. But if I download this using the Docker command, I'm going to get about a 100 megabytes sized file. So that's all the images are. So think of an image as a template, basically, where you can now build applications on. And that's what we're going to show. So I'm just going to go to the black screen. I hope everybody still sees my screen.
Yes.
Okay, good. Docker by itself, they've made it very simple. Anyone who's worked with VM knows the steps we have to go through, setting up the file size, the different configurations, and the OS. Docker right now just has about 32 commands, and you can see those commands by just typing Docker. That's after installing Docker. So there are about 32 commands here, and we wouldn't go through all of them. We'll go through most of the prominent ones. So I mentioned that there's something like the Docker image. So first of all, let's see how do you pull an image. So how do you pull an image from a repository? To do that, let's first of all use the Docker command called the ps command, which basically shows the images in your system. So if I type Docker images, right now it shows me there is no image. I'm expecting to see some images here. And if I say Docker ps, which is a command for the containers, I get the same a blank file. And by the way, I can send after this demo. Feel free to reach out to me. I can send out a list of commands for Docker. So to pull a Docker command, basically, let's say I want to pull a very small image, like Debian, for example, the Debian operating system. So I can say Docker pull Debian, and it takes about a minute or two. So basically, what it's doing now, it's going to the registry. It's going to this registry here and pulling out the Debian image. And we see it's pulling down. It's going to be small. So you can see here it's actually 59 megabytes. Like I mentioned, the ISO files for any of these operating systems, any of us who's worked with operating systems know these are huge files. So it's just going to take about a minute here. So while that's going on, we'll just look at, there are many images you can pull. It could be Ubuntu, it could be Redis, or whatever you're building your application on. For the purpose of this, we're going to use, there are two ways you can build applications based on these images. You could actually manually type in the commands, or you could use something called a Docker file. So a Docker file is basically a sequence of commands. The same commands you would type manually, you basically put it in a file and name the file Docker file. And then...
So, Galvin, question here. Does it have a UI also, Docker?
Right now, there is no standardized UI. Companies like Orchard are trying to build a UI. Drag and drop clicks. And there's some open source UIs. There's one called, I can't remember the name, but basically none of them is standardized yet. Most of them still have their bugs. Yep. Okay, so so now it's completed. Sachin, I hope that answered the question.
Yes, thank you.
Okay, all right.
Yeah, so Godwin, how does the container file ensure the compatibility with the host OS and the host kernel, basically?
So when you're creating a Docker file, when you basically specify what operating system you want. So and I'm going to walk through that here, but I'm just going to skip a little bit. Here's an example of my Docker file here. So anything in these are just comments here. So basically, I'm telling it here, and I set the base image to Ubuntu. So this could be Debian, it could be anything I wanted. It could be Fedora. Basically, I specify what I want.
No, was your question something else?
Well, yeah, just so that whatever you're downloading is compatible with the kernel that you're running.
So basically, as I said, the funda is that since the kernel is shared, you cannot have a Windows Docker or running on a Linux one.
Just within the Linux domain.
Yeah, within the Linux domain. So once you have installed Docker, it basically checks everything, and the kernel has to be above certain version to even run this, to have all the kernel features supported to have run Docker. So whatever it downloads, means if you are trying to download a very, very old version of Ubuntu, for example, I don't think you will be able to. For example, Ubuntu 9 if you want.
Yeah, that's exactly the question.
Yeah, that's exactly.
I stop it is what you're saying.
I haven't tried it. We can give it a try.
Subbu, I can answer that. Yes, you can accept this here. If you notice, I put Ubuntu then colon 1404, which is basically the version. So I could say Ubuntu 10. But what it does is it throws you warnings. I've actually tried that. It throws warnings. So if I install Ubuntu 10 and I installed at the bottom here, I said install something like Nginx. Nginx by itself requires Ubuntu 12 or higher. So it's going to throw you a warning, it crashed. So that's what it does.
Okay, thanks.
Yeah. So it says downloads complete, download of the images. So I could see what images I have by saying Docker images, basically running the same command I ran earlier. And if I say Docker images, now I see that I have, because I did not specify what version of Debian I wanted, so it basically pulled all its Debian versions in the repository. You can see here experimental, version 7, version 6, 6.0, SID, Jesse, basically pulled everything. So I could have been more specific and said Docker pull Debian maybe 7, and then I would get only a small file. But one thing I want to highlight though is the size of the files. If you look here, let's look at the latest version, which is Debian 7.7 here. You can see how small it is, 85 megabytes. So basically it has removed all non-required libraries and basically provided you a very small core operating system upon which you can build things. So that's that for images. The next thing we're going to look at is having got the images, which is basically an operating system. The next logical step is let's build an application on top of this. So an application in the Docker world is basically your container. That's where you list the applications you want to build. So for the purposes of this demo, I'm just going to wipe out everything, make sure we have a clean system. And one thing I'm going to do in this demo is Docker commands tend to be a little verbose, which is why someone asked about the UI. So I've automated some of the commands, but just to remove some of the magic, I'm going to show you what the commands are doing before I run them. So right now I want to wipe out, basically clean out my system. So this is what I'm doing. This is what the command I'm going to say. I'm going to run a file called wipeout, which is the file I created. And these are the commands it's running. It stops all containers. It removes, RM means removes all containers and images, and basically wipes everything out. So I'm just going to do that right now. Again, I'm just trying to be transparent so that it's not all magic, but at least let's spare you the typing. So it's deleting all the, okay, it said from to remove one of our images, Docker images. Okay, so basically, right now I have nothing. I have a clean system upon to build on. So I'm just going to go ahead, start a clean system now. I'm going to go ahead and use my Docker file and build. So at the end of this demo, we're expecting to see a working web application. So, and that is defined, this Docker file here. So here I'm telling it, install Ubuntu, or use Ubuntu, then install Nginx. Nginx is just a web server application. Then in the background, I've created some CSS and HTML files, which are not the purpose of this demo. So I will show you the files, but I didn't show you. Go ahead, Sajid.
Alan had a question.
No, I'm looking for an example about can you run, for example, Fedora on CentOS or Ubuntu are very same.
Absolutely.
They are very same.
Absolutely.
What could be something that is not compatible between the two Linux?
Yes, Alan, you can do that. Yes.
Kernel-wise, it's mostly the same. That's why you're able to run.
Okay, I'll get to it.
So by the way, just one addition to what Godwin is saying, and this is in response to one of the questions Alan was asking is, so the installation of the applications as Godwin is showing is one way of doing it, is the graceful and easy way of doing it, but you could also just bring up a container using a bare minimum image and then go inside and then install your applications manually. That could also be done. So Godwin is showing an automated way of bringing up a container, which when comes up, everything will be done.
Correct. So I could on the command prompt here, I could basically type in all these commands and it will create a container. Then the container, remember the container is basically like a VM in quotes. So I could go into the container itself now and then create my applications inside this container. But I've chosen the easy way, if you will, which is basically using a Docker file. So I'm going to run a command, the build command. Again, like I said, I'm going to show you what the commands do. So basically, the build command itself is very easy. It's basically 2 lines of command. So I'm telling it, use Docker command and build using my Docker file. Build an image called Sanctus G Demo November 14. And this, you will see why I use that name. I will explain to you later why I use that random name. That actually is my GitHub name and my Docker Hub repository name. So, and you will see the need or why I use that later. But basically, what to note is that the container is going to be called Demo November 14. So by the time I run Docker images again, I should expect to see an image called November 14. Then I've also told it, well, let me pause at this point. I don't want to confuse you, but let me pause here. I'll come back to this file, but I'm going to run that, the build file. I'll come back and explain what the second line does, so it's not confusing. So let's go back here and say, make sure we have nothing running, Docker images. Docker images. There's no image, Docker PS, no container. So I can now say source build, which is basically running my build file. So what it's doing now, it's walking through the Docker file one at a time. And as it builds, you feel free to look at what it's doing. So this is just going to take a little bit, and so right now it's running up to updates. It's updating the operating system. Meanwhile, any questions while we watch the screen? And you may get some warnings as long as it doesn't break. That's okay. Those are just warnings, SSL and SSH warnings. We shouldn't worry about those certificate warnings. Questions, concerns? Okay, I'm just going to go to the next tab while that's running. So if I run Docker images, okay, I see now that I have two images. Now, I have one called Ubuntu, which is what it downloaded, and I have one called Sanctus G demo November 14, which basically matches what I expected in my Docker file. Okay. Now, if I say Docker PS, I notice that I have a container now, so whereas before I did not have a container. So now I'm going to go back to my file and explain to you what the second line does. So basically, this first line here, this first line builds the image, and this second line builds a container from the image, So this second line, I'm saying, using this existing image, November 14, build me a container with the name VZDemo. Well, I use that because this was for Verizon. This is what we used for Verizon. The name is inconsequential. It can be anything. But the important thing here is, remember, a container by itself, a Docker container, is isolated. You can't talk to it from the outside world. So, but to get around that, I've told it, expose, let's go back to my file, my Docker file here. I'm trying to make sure that I can see what's in there. So basically in my Docker file, which I did not walk through, but basically at the bottom here, I told it expose 80, which is basically telling it open port 80 so that the outside world can reach it. And knowing that, in my build file, I now say, since I know that port 80 is open, in my local system, use port 49152. Again, this number, other than port 80, this number is arbitrary. It could be any number. Just check with your IT department, know that whatever port is open. So, and it builds that. And if I go here, go back here, so basically it's built this container here, and this is the name here, this is the image, using the image. So you use that image and gave it this name, VZDemo, and the port. So it redirected port 49152 to read port 80. And to see if it works, which I should have shown you earlier. So if I'm expecting that if I go open up a new tab and say the IP address of the machine is 10.84, and this could be a domain name, but in this case we're using 49152.
Godwin, it should be colon, yeah.
Yes. Okay. So basically, this is what I see, and so basically, this is the static web page, which I just put up Haddock. It has some dynamic things, but those are not really the focus of this demo. But basically, so this static page now, which I created, think of it, it could be in a business, in an enterprise, it could be a billing system, it could be a ticketing system, or it could even be a custom application like e-commerce system that the company builds. And Subbu mentioned Google, where they use Gmail. So it could be hosting our Gmail application. So, and so I'm going to do one thing just to show what I failed to do at the beginning. I wanted to come to this page before I ran it so that we know that it's the magic is not, we're not just doing magic. So I'm just going to, for benefit of time, I'm just going to rebuild it all over again. I'm going to wipe it out. And it's just going to delete everything.
Godwin, will you be pushing it to the repository?
Yes, I will push it to the repository and I will pull again. Yes. Yeah. Okay. So right now, if I look here, images, it says my system is clean. Docker, if I could spell, PS, it's empty. So let me rebuild it all over again, and but let me use a different port number this time. Nano.build. Just going to use port 49153. Again, I'm just trying to show that, you know, make it a little bit more meaningful. Okay. So we're just going to run the same command. Okay, now I said port 49153. Let's see if anything exists on that page. 10.84.20.7 9153. That page doesn't exist, and the old page also doesn't exist because I've wiped the system out. So let's quickly build it all over again. Questions while we... the audience is quiet. All right, so the system is building all over again, and we're going to go back to that same page and prove basically, or see that basically it's the container that's driving that web page. So while that's downloading, since there are no questions, and we're going to go back to the page. Go ahead.
Yes, Godwin, I guess I'll be the idiot here and I'll ask a question. So the place where you're running this right now,
yes,
like the command that you're running right now, what is the, where is that running? What kind of box is that on? What is that?
This box is it's sitting on a blade in the Houston lab. So I used basically like a PuTTY-like thing to SSH to the machine.
Yeah. Okay.
So I'm running to.
You're SSH into that, and
correct.
before you started any of this demo using any of this Docker, you went through a process where you did an install, a simple install on that.
On that machine. Correct.
Yep. And on that machine, you're using what is the Linux OS that's running on that?
Right now, it's running Ubuntu.
Ubuntu.
So it's running Ubuntu on that, and you did a simple little Docker install.
Yes.
And then everything else that you've been doing here has been with only that having been done to that source system that you're using.
Correct. And Mark, you make a good point. And so before I did this, I had to install Docker. I had to go in and download Docker. Then in the back end, because the web page didn't it's not Docker that built the web page. So I, again, since the demo wasn't on web design, but I did build, if I click the directory, there's some files which I created, like the index.html, which is an HTML file. There's some CSS files, which I basically used to build the web page. So think of it like I built the application, but now I want to put the application inside the container.
Yeah.
But for the purpose of the demo, I did not just show how I build those applications.
Yep. So you basically went to Docker after the install in your local Ubuntu environment. You went up to Docker and pulled down an image that gave you a base, and then you added some stuff to it to be able to do the HTML demo.
Correct.
And then you deposited that back up into Docker?
That is correct. Well, I haven't done that. I haven't done that part yet. So right now, everything I'm running is working locally. Okay. So in the next stage, in the next step, I'm going to show you how to push it to the Docker repository, the Docker hub, and how to pull it back.
I see.
if I need to. Yes.
Got it. Okay, thank you.
Yes. Yep. So, let's see if our Docker image is built. Okay, Docker image is built. Docker PS. We have a container running on this port 49153. So I expect on my local machine now, because this is, I've told it to expose port 80, but on my local machine, which is my Windows laptop here, I expect that if I open up a browser and go to port 49153, I should see the same web page again. So I say 49153 and it works. So that's it. So like I said, this could be an application, it could be CMS system, or anything else.
Now, Godwin, I'm going to go back to one little part that has me a little confused. Okay, so your source system is Ubuntu, and when you showed the Docker, website where you could go up and get various different things.
Yes. Let me open up the Docker repository, you mean?
Yeah.
Okay. Let's see if I can find that, minimize this. It's one of these tabs here. Repositories, yep. Let's see, okay, let me hide that.
Yeah.
Okay, so, go ahead, Mark.
So all those things right there, clearly, you show Ubuntu listed there, but you also show other stuff here that wouldn't necessarily be appropriate for Ubuntu. And go ahead.
No, go ahead, please. Go ahead. Finish.
So your source system being Ubuntu, you can go get other images off of here and pull them down that wouldn't normally be compatible with necessarily Ubuntu. Is that?
That is correct. Yes, and I can see where the confusion kind of lies, because my Docker file also uses Ubuntu. So like I said, my Docker file could be Debian. It could have been Debian, and it would still work. And I actually have another demo which, for benefit of time, I can show you. It actually uses Debian, and so basically it's think of it as like an Ubuntu box sitting on top of Ubuntu, or a CentOS box sitting on top of Ubuntu.
I see.
So it could be anything. Yeah.
So
other than Windows.
So the host OS
doesn't matter really.
It doesn't matter as long as it's a supported Docker host OS.
Correct.
So does Docker then, under the covers, is part of their job then to rationalize all the deltas between various versions of? No, they don't do that. It's literally.
They actually do. They maintain the images. So every image on the Docker repository that you pull down has been validated, and they give you their guarantee for that. Yeah.
So when you run one of these other images that wouldn't normally be thought to be compatible with running on an Ubuntu box, are you running both, or are you?
I'm running just one, and I'm going to show you. Sorry, guys, I cannot digress, but let me just show you. And I will run that same command. I have it here also, so it will. Okay, I don't have that. I'll look for it while the demo is running, and I will run that. But to answer your question, yes, you can run any of this command. You can run CentOS, you can run Fedora, you can run Debian on top of Ubuntu, and it will still work.
So
it's isolated.
It seems like magic if there's not if there's not virtualization to accommodate the other OS.
Yeah, but Mark, think of it this way: container by itself, is virtualization. I use that word in quotes, but container by itself is virtualization, which is an isolated box.
Okay.
So that's, Raju mentioned this earlier at the beginning. So we're trying to move away from the VMs and the KVMs.
I see.
That might take time to do, but it's basically the same concept.
So going all the way back to, I remember when Solaris introduced this whole initial concept. So back when they introduced it, it was, I think, introduced for the idea that you could run multiple versions of Solaris all in the same piece of hardware. That inside each container you could have, or each partition, whatever you wanted to call it, you could have a different version of Solaris. But this just takes it out to
a different level, exactly. So
to a different level. It takes it out to all the different variations of Linux.
That is correct, yes.
I see.
So I could have an application running CentOS, one running Red Hat, if I have the license, one running Fedora, one running Ubuntu on top of Ubuntu.
I see.
Yeah, exactly.
I see. Okay, that's interesting. Cool. Okay, thank you.
Yeah, you're welcome. Any other questions? Okay.
So Galvin, quick question here. Basically, you mentioned that, I think Subbu mentioned earlier, that you can either install the application later on or have the application part of your image, right? The container itself. So in that case, if it's the latter, right, where you already have the application installed and you're just putting it there, would you actually put it on the repository that you showed up on the World Wide Web, or you would have your own local repository? Where would you put it?
I mean, it's the user's choice, and so the next that brings us to the next step, which is basically, sorry, I stopped presenting. Let me click back again and start presenting again. I was trying to. Can you see my screen?
Not yet.
Okay.
It's coming through now. It's starting to load.
Okay, good. Okay, all right, good. Okay. Just trying to close this little thing here. All right. Do you see the Docker repository?
Yes.
Okay, good. So that brings us to the next thing, which is the Docker repository by itself. So it's my choice when I upload an application, which I'm going to do next, to make it public or private. If I'm a social coder, which is the cool thing to be these days, people do use GitHub and all, I could put it out there for the whole world to use. I could make it a public repository, but if it's like my billing system, I don't want to put it a health system with HIPAA laws. I don't want to put it public. I will make that private, or a Gmail repository, for example. You don't want everybody's email and passwords hanging out there. So here, this just happens to be my username, and I click on my repository, and right now it says I have nothing in my repository. That's because for this demo, I basically wiped everything out. And it says I have, because I'm using the public unpaid version of Docker Hub, I can have one private repository, and I can buy more if I want. And
okay, so question, clarification, when you say private repository on this docker.com, it's still on the World Wide Web. It cannot be within Verizon's own domain. You can't have your repositories there, can you?
Oh no, I see what you're saying, Sachin. No, you can have your own repository. Yes, you can have your own repository locally. So it's basically, think of it like when we used to use the TFS, the version control systems. So the same thing. You could have your TFS worldwide, put it on .NET, or you could put it on a TFS server in-house. So you can have it in-house, or you could have it on the Docker Hub. It's basically the enterprise's choice.
So they have a different set of installation you'd go through in your own local environment to get all the basic infrastructure set up. You'd have separate licensing from Docker to get that kind of repository established.
No, you wouldn't. You wouldn't need if you have to have a private repository, you wouldn't need a license from Docker. Because in that case, yes, yeah. You only buy a license when you want to use docker.hub, and then you want to make it private. And then you click, and then basically you have to worry about their prices. So you could have 50 private repositories if you want, for $50 a month. Yeah.
So that license is really just to cover their infrastructure to be able to accommodate yours. Yeah, got it. Okay.
Yeah, exactly. So right now, I have nothing on my repository, and so what I'm going to show next is basically how to push the image that I've created and into the World Wide Web. And another demo we could have maybe sometime in the future, if you want, is I could actually create a little server, mini server, and show how to create a local Docker server. It's unfortunately not so easy right now. There's a lot of commands and steps to do, and that's why I kind of skip it over for now. But okay, so now I'm just going to push it over. So let's see. I have my, see if I still have my images there, and I still have my containers, Docker PS. I still have that there. So now what I'm going to do now is I'm going to push it to the repository, and I'm going to use my command called push. And basically, this is what it's going to run when I say push. It's going to say Docker commit. So before you push to the repository, you have to commit it, and you commit it, put a comment. So I'm just putting a comment here. Put the poster's name, that in this case is myself, and I put the file name, the container name that I'm committing to, and I give it a name that I want it to appear on the Docker Hub. So at the end of the command, I expect that when I go to Docker Hub, open up this page and refresh F5, that I expect to see something called Docker demo November 17. So it commits it, then pushes it. So Docker push, Docker commit, then Docker push. So let's go ahead and run that and see what happens. Okay, so I'm just going to say source.build. Again, it's just running the commands in that file. Sorry, not build. Push is what I want to run. See, I got an error message because source.push. Okay, so it's sending the image. And we could actually just try to see if I can. Okay.
So it's calculating locally what piece parts really don't need to be pushed?
Yes. It's basically calculating the diff and trying to push just what is needed. It is not pushing everything.
So every time you run a push command, again, it just pushes only the diffs. So that's why it's fast. So it pushes only the changes.
Yep.
So it's basically checking to see if anything has changed. In this case, nothing has happened. So let's see. Pushing for tag. Okay. So let's see if it works. So I expect that if I click refresh, and there we go. So we have a Docker image which has been deployed, pushed to the system, and that matches my Docker demo November 17. So on the World Wide Web, we now have my my container, my image here, and we could just click on it and so on. So anybody, it's now public. Anybody who knows the link can go ahead and pull it down, which is what I'm going to do next. So let's see. To pull it next, I'm going to see. What I'm going to do here is to show how it works. I'm going to basically delete everything from the system and then pull it again. So I'm going to run the wipeout command again to wipe out. It's going to wipe out, remove all images and containers. So if you remember, that removes all containers and images. So if I run that, I expect after running that, if I click Docker images, I would see nothing again. There would be no images. So, source dot and so this is going to take out everything. I'm going to start from scratch. So everything's all deleted. If I say Docker images, the images are all gone. Docker, yes, all gone. So now I'm going to run a pull command to pull it from the web and from the Docker Hub. And the pull command is basically 2 lines, it's saying Docker pull. And this is smart enough to know when I say Docker pull, it automatically goes to Docker Hub, so it's going to go there. I'm saying Docker pull this, pull out this file, pull out this image, and then when it pulls it, it doesn't actually run it. It just pulls it and stores it in your computer. But I want it to be active. So in this case, I'm saying after pulling it, run it, wake it up. So then build an application. In this case, I'm using a different port number. I say when I go to port 49155, I expect to see that application there. So let's see if that works. Source.pull. So it's pulling. And it's faster than building since it's already built. So it's basically just pulling. So this is no different than pulling the OS like I did in the beginning, like when I said pull Debian. It's the same thing. In this case, it's just more okay. So let's see. It told it to go to 49155. I expect that if I go to, let's see, if I open up a browser, all this here, if I refresh, I expect it to die. It should be dead by now because that application doesn't exist again. So I'm just going to click refresh. And let's see what happens. It doesn't exist anymore. But if I change it, the port number to 49155, the application is still there. So that is, for the purpose of time, that is all I'm going to show on this demo. Please feel free to ask questions. And I have other Docker files which I will gladly share with anybody that have different operating systems that run on Ubuntu. Like I have one for Debian. I just have to find it. It's what we used for the Verizon demo. One for Debian and one for CentOS. So any questions, please feel free to reach out to me.
Okay. Hey, thanks, Godwin. So any question, guys, just reach out to Godwin. Any of us, we'll be happy to experiment and let you know if you have any questions. So let's go ahead. We have already, I think we don't have much time. So we'll go ahead demo from Ken, which is mostly about the Docker and CSA integration. So Ken, please go ahead.
I think. Let's just give him a couple more. Sorry, Ken's in a car, I think. Let's just give him a couple more minutes to see if he can join in. Ken, you might be on mute.
I don't know. What's that?
Okay, if Arun, do you know if Ken went somewhere or something?
Yeah, Ken said he's stepping away from the PC. He's going to be driving.
Oh, okay. Then let me go ahead with what I have to show, and then when he comes back, he can join back. Is that okay?
Yeah, that sounds great.
Okay. So guys, what I have been doing actually in the Godwin, can you give me back the session, or is it already with me?
Yes, you can share.
How do I share?
You have to exit the presentation mode and reshare from the link.
I'll do it. Yeah.
Alt tab and find it. Alt tab. You can find it. Find the
where is it?
L. Link, right, bottom, left, right, just right. Yeah, this one. And find, oh no, not this guy.
Hold on, guys, I'm just trying to.
The one on the left. No, this one, the other one, yeah. Yes. No?
I'll get it.
Yeah, one of those. Okay, which one? Here we go.
Like a tape.
Okay, I'm sharing my desktop now, and so what I'm going to show is basically what we have done a little bit with Verizon here. So, what is this? Yeah. So guys, can you see my desktop?
Yes.
Okay, thank you. So what we have done here is, I got a request from Nirlay from Verizon saying that he needed some help, and basically he needed help in determining the resource allocation to Docker containers, and he wanted to have a use case where he would actually monitor a Docker container for its resource usage, and when the resource usage is beyond a certain limit, he would actually spawn a second container. Basically, it's a very classic flex up, flex down kind of a use case which he wanted to implement, and he reached out to me. So he wanted to have, first of all, know that how you can actually monitor when the containers are running, and where actually you can go to get the statistics about different kind of resources which are being used by the container. So what we can do, and when a container is running, basically, as I said, that cgroups is the one which actually monitors all the Docker containers, and for that matter, it basically allocates resources to any container. So when a container is running, you can actually go to cgroups and figure out that, what is the usage. So I'll just show you how to do it in cgroups, and then we can actually go ahead and see a better way of doing it. This is my laptop, by the way, what you are seeing. So I'll quickly show you the place where you can actually go and monitor the cgroup. So this is basically the directory where you will have the kind of cgroups which is present in your system. Most probably, so there is a command called ls cgroups which you can get with your cgroups bin. There is a tool which you can download, and this shows the kind of basically cgroups which is available in your system. By the way, I'm running, just in case you are curious, I'm running Ubuntu 13.10 on my laptop on a VMware workstation. So now I'll show you what happens when you actually run a Docker container on this. So I'll just duplicate this session. So I'm inside, and so I'll see what else is running. Nothing is running here. So I'll just go ahead and using my already downloaded Ubuntu image, I'll spawn a container immediately. So Docker run, as Godwin showed, -d means when the container is attached, I want it to be detached. When a container is spawn out, I want it to be detached. I don't want to be inside the container. Otherwise, you will find yourself inside the container. And T is for terminal. I is, I think, for, I forgot the exact name of that particular option. So I give the image name Ubuntu, and I want the command bash to be working inside the container. when it is done. So once I spawn it, I see that immediately a container is up and running. So Docker PS should show me the container name. See, here is the container. Now, if I go inside the C groups directory, so if I go inside CPU accounting, you will see that there is something called a Docker directory. By the way, just to show you that, where did it come from, I'll just stop the container and start it once again. So I'll do a Docker stop. Let's go back. No, it's not going. Sorry, it was a mistake. I'll just start it. So, if you go inside Docker now, okay. So here is the thing which actually gets the statistics. So you can see that this is the place. This is the exact place where you can have all the statistics pulled. But this is a very, very raw way of actually getting the statistics from C groups. There are other applications already available which can do it for you. One of the applications very popular in getting the resource metrics for Docker is something called dog-tag. But again, I found out later that there is a better application, and that's what I'm going to show you now, that how you can actually get a very nice representation of all the Docker statistics that is running in your host. So what you have to do is, basically I came across this application from Google once again called C Advisor. People who are from the BCS background will find this name very, very familiar, because we had a product called C Advice that used to run, this command to see if your code is good enough for Itanium platform migration. So here is an application from Google called C Advisor, which actually lets you collect all the information about your Docker containers. What we'll do is, first let us spawn quite a number of Docker containers. So I'm running, this is one container, another. I have spawned 4 containers, and already a first container was already running. So you can see Docker PS. I have all the containers running here. Okay, and this is the ID of all the containers. So, and Docker gives it a name already. If you see, these are the very funny names they give, and some of them you cannot make out the meaning of the name. For example, this name is Cranky Tesla, so the 4th name. So it automatically gives it a name. So basically 5 containers are now running. Let me go ahead and start C Advisor. How to start C Advisor? Now C Advisor is delivered to you inside another Docker container. As Godwin showed, that you basically have a Docker file to run this. So C Advisor is, if I run this file, it will basically follow this, and with the help of this image, Google/C Advisor, which I have, by the way, downloaded, because I have some connectivity issue with my laptop when I am at the office with this particular VM. So I have actually downloaded this, and while doing it, it will actually build this Docker container and install C Advisor inside it. So we'll go ahead and run this. Okay, our C Advice container is also running. I will go to the Docker page and just do a Docker PS. You will see that the C Advice container is also running. and there is a port mapping of 8080 of the local host to the containers 8080 port once again. So now what I'll do is I'll just go to my laptop's browser and now let me see what is the IP address of my virtual machine. So as you can see, the IP address is 128. It starts from 128. Sorry. So I'll just spawn off this along with this, and you see the CAdvisor is up and running. So what does this gives me? Now if I go to subcontainers, you will see I can see all the containers which are running here, including the container in which CAdvisor is running. Now let us see how much CPU Cranky Tesla is actually consuming. Now if you go, you will see all the usage marked here. Obviously nothing is going on here, but if I could run something inside the container, you will see this immediately shooting up. But this is something which gives a very good insight into the per container resource usage. And please note that everything which I am showing is actually collected from C groups. Now CAdvisor has a very good REST interface also. You could write clients which could actually extract this information and use it. So this is a small demo I just wanted to show you about CAdvisor. Please shoot me any questions if you have anything. So Mark, does that answer your question? You had a question about the resource allocation?
You know, it answers any question I would have had, yeah.
Okay. So that is all about CAdvisor. This is the small thing we did with Nirlay. I haven't really gone back with CAdvisor. I'll do it today, in fact.
Hello. Can CAdvisor predict where the next container should be created?
Can you be a little loud, Ken, please?
Can it predict where the next container should be created?
Can it predict? No. It doesn't do that actually. No. Right now the capabilities are quite basic. You do not have much, but yeah, it doesn't. It does. To answer your question, no, it doesn't. So Ken, since you are back, my small demo with CAdvisor is done. So you can continue with your demo if you're ready of CSA plus Docker. So guys, any question on CAdvisor?
Thank you.
You know, yeah, this is Mark. I guess I do have one more question. So, because the container runs inside of a piece of physical equipment, is there a way? I thought maybe there was, but it's probably outside the scope of what can be discussed here. There is a way to be able to slice up your resources like memory and CPU and assign them to a specific container. Is that true?
Yes, you could. Yes.
Yeah. Okay. Very good. Thank you.
Yes, you could actually. You could actually make sure that your container always gets a fair share of the CPU. Yes, that can be done.
Yeah. Thank you.
Okay. Thanks a lot. So Ken, please go ahead. I'll just stop sharing.
Can everybody hear me?
Yes.
Okay. Don't have a demo right now. Recreating the demo. Just want to take a step back, and what we're going to do is show vCenter-like or a container, a host container management solution. We mentioned a few of them today. I want to show that managing.
Ken, you are becoming feeble at times. Could Could you come to the mic or something?
Hold.
So if you've already attempted to make a correction, you now can't be heard at all.
Sorry, my hand hit the mouse, hit the mute button. Is this better?
Talk a little more.
Okay. Yeah, we can't hardly hear you, Ken.
So what I was saying is I want to do a demonstration where the HB solution is looking at a manager of managers, and that manager of managers is looking at least 2 hosts that contain the containers, and then we will spin up an application on both hosts that will demonstrate some type of application that Verizon would put in a container, whether that's business to business or business to consumer web page. So we present it almost like if we were looking at KVM or vCenter, where Docker is just what the application would run in. So we want to reconfigure the demonstration to do that. Any questions?
Ken, are you presenting something? Because it's not.
No, I'm not presenting anything. I'm just talking.
Okay.
So do you follow that line of reasoning?
Yes.
Yeah, take me there one more time, please, just so I make sure.
Right. So the physical hosts will host the containers. So we will present an application that's running in a container, similar to the demonstration that was done on the command line. But we will have our HB solutions look at a management solution like I think it's Mezzo, or there's another one. And then Mezzo, when we ask it to launch a container, it will decide on which host the container should be launched on, one, and then we'll just look at what the application is running in the container. So we take it up a level from just launching the container from the command line, and we start to put a decentralized manager of managers on top of the containers, and then we can start projecting where we can have 20 physical hosts that will host the containers, or a farm of them, and we will be integrating with Mezzo that sits on top of all the containers, similar to what vCenter does. Does everyone understand that?
Yeah, I get it.
Right. So I guess it's the next step in, yes, you want to use Docker, yes, you have containers, and now we'll integrate with the manager of managers rather than integrate with individual containers. Because then you can start talking about, what if one container was down or one host go down, and you can swap them in, swap them out, and still have the application be available across many containers, and the HB solutions just talk to the manager of managers, and that takes care of where to place the load and where to migrate load and things like that. So that's a demonstration I want to create.
So, question here: why Mesos, Apache Mesos versus Kubernetes, or are they different in the new functionality, or they're pretty much the same?
I think they're the same, and I think I was thinking about Kubernetes first, so we'll probably go that route. Whichever is easier to set up, because I think they're both under development, and the basic functionality to manage the host the containers run on, that's what we want to demonstrate the integration with. It doesn't matter if it's Kubernetes, excuse me if I'm not pronouncing that right, or Mezzo. We just want to abstract away from individual hosts that the containers run in and go to a manager of managers. That way we can position that, HB can deliver, 24 servers to be Docker host, and the containers can run these 24 servers, and we'll just pop them in and do the management through Mezzo or Kubernetes. instead of the individual host. Just kind of elevating our game, that's all. So the team and I will work on that demonstration and start pointing to the manager of managers instead of the individual containers. I'll turn it back over to you.
Thanks, Ken. So just to quickly recap, we had a session where we talked about what containers are, why we need them, how the internals of the containers look like. We had two demos, one using the C-Advisor and the other is using the standard top-of-the-trunk Docker demo that Godwin shared. Ken talked about the integration of CSA and Docker. So I think that hopefully paints a picture of what we've been able to do today. One of the other questions that customers have for us is, how does HP plan to bring in Docker into HP's vision of what cloud enablement is? So for OpenStack, we have an answer. It says, we have Helion OpenStack. We bring in these services. We certify these services. We add these additional layers around each of these services. But we have to be able to explain to our customers what our strategy around Docker is as well. There are a number of different ways to bring in Docker into the environment. HP is committed to bringing Docker into the data center as part of our product suite, but I think the details are still being worked on. The last update I have is around how Docker and Kubernetes could be integrated as part of HP's development platform, Helion development platform. So the development platform is again a collection of products that sits on top of Helion OpenStack. If you want to look at them from the functionality that they provide, you can look at Helion OpenStack as the component that provides the infrastructure services, network as a service, compute as a service, images as a service, storage as a service, while development platform brings in application services. So infrastructure services for Helion OpenStack, application services for Helion development platform. So your database as a service, message queue as a service. All these components are being packaged into what we call Helion development platform, which is Cloud Foundry based. So the current HP strategy is to bring in Docker via the Helion development platform initiative. So I'll quickly share a couple of slides we have that talk about what are the various options we have today for Docker and how we want to position it for our customers. Sakar, can I go ahead and share it just as is? Give me a second. Let me share the presentation. One second. Just a second. Can you guys see my screen?
Not yet.
Yeah, not yet.
Okay, just give me a second. I have the different screen. Come on. How about now?
Not yet.
Let's give it another second. If not, I'll just go ahead and share my entire text. Okay, it says here uploading.
Yeah, it's loading now. It's loading.
So this is what we shared with the Verizon VCP team when they were on site in Houston for the VCP Phase 1 demo last month. So
We can see the slide, an introduction to Docker.
You can see. I cannot see the slides myself. Just a second. For me, it still says it's loading. Give me a second. I'll keep it brief. I think we have like another 15 minutes, so I'll keep it quite brief.
I could go through the slide.
So Sarkar, if you can go to slide 15, that's the one I wanted to talk about.
Can everybody see slide 15?
Yeah. Not yet.
Not yet.
Not yet.
Not yet. It's just slide 1.
Or is it just my thing which has changed?
Link is playing tricks.
We can move it ourselves. Oh, we can move it ourselves, each individual.
Oh, everybody can move to slide 15.
Yeah.
Okay.
I'll go
if you guys
15.
can just go to slide 15, that'd be great.
That's why it took a while to load.
You're right.
Okay, perfect. Now I can share as well. Okay. So slide 15. If you look at how Docker fits within the ecosystem. So today you have a distinct set of products that play in different spaces. So at the lowest level, you have the hypervisors or the para-virtualized environments. KVM provides a hypervisor, ESX provides a hypervisor, and Docker provides another para-virtualized environment. On top of this, you have OpenStack services on one side using various different means to provide you access to your underlying hypervisors. You have HP's CSA set of products which also aim to provide infrastructure and platform as a service. And then you have NFV Director, which tries to bring all of these things together to provide your infrastructure as a service or your VNF as a service. So what are the ways that we have today where the integration already exists? So OpenStack can give you KVM as a hypervisor and ESX hypervisor, and it provides a couple of different ways to leverage the Docker environment. The first is using a Docker driver that Nova can directly work with. So Nova, which is the OpenStack compute service, relies on a hypervisor driver to be able to talk to and provide the compute as a service that it owns. For example, for a KVM environment, libvirt, there is a libvirt driver that Nova will use to talk to libvirt, which will in turn talk to KVM. Nova also can use bare metal hypervisors to actually use, what Ironic uses today, to access your node as a bare metal node, push an instance on top. In a similar vein, Nova can also use a Docker driver to have Docker as your quote-unquote hypervisor or para-virtualized environment. So this driver used to reside in trunk along with OpenStack, but for some reason it was spun out. The reason that was given was the development cycle of Docker was different to the development cycle of Nova, so the Docker driver effectively lived outside the trunk. There are efforts on to integrate the Docker driver back into the trunk. Maybe it's already in, but as of recently at least, there were efforts on. So this would enable Nova to use Docker as a driver, just like it uses libvirt or the bare metal hypervisor driver, to provision instances based on need. So your scheduler will look up a flavor and it'll look up a couple of other parameters, and then would be able to decide on where to push that quote-unquote instance. If it's a VM image, it pushes it on KVM. If you want to push it on ESX, it pushes it on ESX. If it's a Docker image, it knows which hosts are running Docker hypervisors, Docker drivers, and it pushes to the Docker instance. So that's one way for you to bring in Docker into the environment via OpenStack. The second is there's a Heat plugin that uses a Docker driver again to push the instances on a Docker driver. I really do not think this is the direction the community will go, but that's an option that is available. And thirdly, OpenStack is also working on a service called Magnum. Magnum aims to provide container as a service, effectively try to do what Docker is already doing, an API-based, lightweight environment that OpenStack can.
Arun, are you seeing at slide 16 or 15? Because 16 gives a better view of the same diagram.
It does. Just a second. Okay, yeah, slide 16. So what slide 16 tries to do is it helps you understand, slide 16 and slide 17 actually, it helps you understand what is a better way for us to bring this into the environment. So maybe I'll go to slide 16. So as you can see here, OpenStack has ways to provide it. Similarly, CSA also has ways to provide it, as Ken mentioned earlier. CSA can talk to Docker, CSA can talk to KVM, CSA can talk to ESX, CSA can even talk to OpenStack and then have it do all of this on its own. So that's an entirely different stream that you can explore depending on where the customer's interests lie. And together, these two can provide the underlying platform for NFV Director to talk to instantiate these resources. So as of today, there are various layers that are part of this deployment, and HP has components that play in each of these layers. Some already have integrations, like for example, CSA, while some would have to work to acquire those integrations, like for example, NFV Director. So the next slide, slide 17, talks about, slide 17 talks about what are the ways that exist for us today. The green lines, the black lines are direct mechanisms to get the service. The blue lines already exist, while the green is something that we had proposed for Verizon, given that they already had an interest in cloud services in CSA through their IT house. CSA already has integration to Docker, and by NFV Director talking directly to CSA, you'd still be able to get a quote-unquote NFV-enabled environment managed by NFV Director, but uses Docker as your back-end para-virtualized environment. So I think we have like 10 minutes more, so I'll pause there for any questions.
So, Arun, are we building the Kubernetes and Mesos functionality based on the green lines into the HP CSA?
So Kubernetes and Mesos are in plan to be included in the development platform, Helion development platform, which will bring in the Docker engine and all the other Docker components as well. I understand CSA already has plans to use Kubernetes to talk to Docker. Ken might be able to provide additional information, but the goal is for the existing infrastructure as a service providers to be able to talk to Docker using various means.
And there was actually some announcement regarding the integration of Kubernetes and Mesos also. So basically, just for the background, Mesos is a Apache project which is basically a cluster manager, and then you have Kubernetes, which is a orchestration engine, open source orchestration engine by Google, which was very much tied to the Google Cloud platform till very recently. Now you can actually go ahead and download Kubernetes and run it locally, but I think we can expect a lot in these two fields going forward. Especially the Mesos guys have shown a lot of interest in integrating with Kubernetes and giving a one solution.
So basically, my question is, where are we now? Where are we 6 months from now? And where are we after that, right? That's what I was trying to understand. So what you're saying is the blue and greens always coexist, right? Depending on what the customer wants.
No, what I wanted to say was the blue functionality exists today in that NFV Director can talk to OpenStack using the REST APIs, and OpenStack has the capability to use a Docker driver that's living outside of the trunk to boot up Docker instances on your para-virtualized environment. So the blue lines are something that we are doing, and that functionality exists. The green was what we suggested to the VCP team, given that they already had an interest in CSA from their IT house, and CSA already has the integration with Docker. So if NFV Director wants to work in a non-OpenStack environment, it already has a way to talk directly to CSA and through CSA invoke the Docker containers.
Okay, so de facto deployment will be blue unless customer wants it differently, then we go on to the green depending on the requirements, right?
That is correct. That is correct. So so the Docker driver today, as I said, lives outside of the trunk. So
right.
when is it going to get into quote-unquote Helium OpenStack? If it still lives outside of the trunk, what does the customer want to do? Because we can certainly show a demo from upstream, but how does the customer want the support to be? So I think those are some of the considerations that we have. If all that is a significant consideration, then we always have the green line, which is CSA already talks to Docker. The benefit director would talk to CSA, and then just follow the stream.
Arun, one question. Is there any talks of having the Docker driver inside OpenStack by Kilo? Have you heard about?
Yes. So, I mean, the only doubt I have is whether if it's already back inside. So, I'm trying to remember who. So there were discussions around getting back the Docker driver and putting it onto the OpenStack trunk. Was discussed in Paris in that OpenStack summit. I just need to go back and dig through to find out if it has already made it or it's still in plan.
Cool, thanks.
Okay. So there are no more questions. Just again a quick recap. So Docker has gained significant interest and mind share with some of our customers, especially Verizon, which is very, very keen on understanding what they can and cannot do with Docker. As HP, we align with what the community is doing. We align with what other customers are doing in the space. We do have various different options available to us through our slew of products. There are additional capabilities that are about to be enabled, for example, in the Helium development platform. So the goal, or rather the message for our customers from us would be, we are open to provide you with any underlying virtualized environment that you need, and either via the technology that's community-based or via the products that come out via HP, we can certainly address any design constraint or restriction that you might have. So that's all I had. So I'll probably pass it back to Raju and Lori for any closing comments.
Raju, Lori, still there?
So one point I want to make, so I saw some slides. We saw the slides initially, which talks about Dockers and NX containers, right? Is there any plan for sales perspective, or the knowledge share, or showing HP's capabilities of understanding all this to put it into some slide share online somewhere, or is it already there? So it shows up on Google and those kind of things.
I don't have an answer to the question. So this was a collective slide deck that Subhrangshu, Godwin, and Tariq actually put together. I don't know if there's a plan. Much of this information is, I'm not even sure, is shareable yet. For example, development platform, they need to make an announcement. But once we make that announcement, once we have it in a product, I think it will be much easier for us to take it to slide share, like you just mentioned.
So, if we have a second, Arun.
Sure, please.
So, when a client buys into, kind of the traditional OpenStack kind of approach using the virtualization, not this whole container concept, versus when you go the container concept, is there fundamentally any kind of significant concern for the future with respect to how you would deal with patch management, upgrade to new versions, things of that nature? I mean, is it more messy with one versus the other, or is it really just not a factor?
No, I think they both try to do right by some of the factors that you mentioned, upgrades. So again, it goes back to the pet versus cattle in that the upgrade cycle, the refresh cycle for VMs is significantly different from what we used to do with regular hardware, and the same concept would apply regardless of whether using KVM-based virtualized environments or Docker-based para-virtualized environments. I think a couple of other things to consider would be, so the KVM environment is fairly stable. Docker is coming up. Where does the customer's interest lie? Do they want to go to a stable environment which has some implications, or do they want to go to an upcoming environment which again has a different set of implications? what are the advancements that are happening in each of these different options that we have. KVM is undergoing upgrades all the time for performance reasons. How does that translate into a Linux container or a Docker-based environment? Is Docker the right way for us to even deploy Linux containers, or is there something else? So I think those are the kind of questions that we can bring up to the customer and discuss. At the upgrades or essentially rolling into a newer environment, I think they're both similar in that they want to address the same problem in similar manner.
I see. Yep. Thank you.
No problem. Yes, Sajid, I think you had a question. Someone had a question. Oops. Okay. So it's 3 Pacific, so we are at the top of the hour. So if there are no more questions, I'll close out this call. Thanks again for your time. Thanks to all the presenters for sharing your information and taking time to talk to us. Guys, have a good evening.
Yep. Thank you. That was great. Appreciate it.
Thank you, guys. Bye.